class. Good to be with you again. What we're going to do today is StatTutor19.1, Risk Factors for Low Birth Weight. Big picture, there's 3 questions. The first 2 are going to be chi-squared tests of independence. The third one is going to be a t-test, which we already did in StatTutor18.1. Taking a look at the data here, we've got a variety of variables. We're going to be focusing on the low birth weight variable. 0 is normal, 1 is low birth weight. Age, we'll also look at, let's see, the race, and then smoking. Okay, so with that, let's jump into it. The scripts are relatively straightforward. Question 1 is low birth weight related to smoking. So basically, we want to come up with a table that has the smoking data and the low data. Not sure if you've done this before. That good old table command, we can run it with 2 variables in it, and it will produce a 2-way table. So let's just do TBL and dun, 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 smoking and low. Now, one issue here, it doesn't have the labels, and the variable names are the same in both. So we should have smoking here in the rows and low birth weight here in the columns, I believe. So if we run the next row here, this is converting into a row sum format. So notice about 75%, 25%, 59 to 41%. Okay, so low birth weight, let's see, we get 74% here in the non-smoking group healthy versus 25% low, and then 60% in the smoking group healthy, 40% low. Looks like there's a difference there, just by eyeball. Okay, to actually run it, the chi-square test command syntax is very, very simple. Basically, it's chi-sq.test, and you put in the data. So TBL is my data, that's this object here. So we're just going to pop that in, and see it is q.tst TBL. That'll do it. There's an optional argument, like when we're doing the let's see, we had an optional argument with the correction factor, and so we are going to pull out the correction factor because this will give us equal results to our hand calculations. So there it is, p-value 0.02. You can see it's a little different, it's not hugely different. We'll go with the uncorrected, and that's below our 0.05. We will reject the null hypothesis, and we'll conclude that there is a dependency relationship. That's the null, that's the alternative. The alternative is there is a relationship. And so we saw that smoking is related to a higher proportion of low birth weight babies. Okay, so that covers it. Now, in the next question, we want to check, same concept. We're going to look at the low birth rate, but we're going to check race. Okay, so low birth rate and race. Now, we'll run the table. It's identical syntax as before. We only changed race here from what it was before, smoking. Okay, so we get the table, TBL. There it is. There's 3 values of race. I believe 1 is white, 2 is black, 3 is other. Okay, and then we can do this percentage conversion. So white, we've got a 76-24. Black, we've got a 58-42. Other, we've got a 62-37. 63-37. Okay, they do look a little bit different, don't they? Well, let's check the test, see what we get. Again, it's the same syntax as before, 0.08. So it's low, but it's not crossing our threshold. This may be a case where you see the arbitrariness of that 5%. It's simply an objective benchmark that we set prior to running the test. 0.05 is not a magic number. Some people will set 0.01, some people 0.1. It depends on your overall objective and the history in your discipline. With psychology, yeah, you guys use 0.05 typically. Okay, so there we have it. Last question, is low birth rate related to age? Okay, so we're just going to run in here, do the descriptives. Let's take a look. Age here is a numeric variable. Low birth weight we've already seen. So just running the standard box plot with age on the response. Now honestly, you might want to think of this in the reverse, that we use age as an explanatory to predict low birth weight. It's a very rational thing. If you're thinking that, it's very rational. They did it this way because it's what we know how to do with our tools. That's really the reason. So it's more for pedagogical purposes than it is for the way we'd really approach it. Just let's be clear about that. So we get the box plot then, having age as explanatory. We'll run the mean, median, and standard deviation, just some other stats using the exact same format. Do keep in mind that we need to have the Mosaic library turned on. So let me go ahead and turn that on right here. Library Mosaic. Okay, great. Now, as far as the formula analysis goes, we're going to run the exact same syntax, age by low, but we're going to have a mean that's the null hypothesis. We'll specify the alternative hypothesis type, and that gives us our t-test. We run that guy, 0.07 p-value. So by eyeball, when we look at these, they are pretty close, aren't they? Not too huge of a difference. There is a little difference, and so it's not so big that we were able to detect it at the 5% level of significance. Therefore, we'd say not too strong. If the sample size were increased, then presumably, if all things were equal, then we would wind up detecting it. Okay, but the focus was on syntax. I think we got it covered there. Lord bless you.